So because of these two difficulties, using two reference point method to calibrate a thermometer is not used after 1954. Next, after 1954, method in use after 1954. So Kelvin, another scientist, suggested that instead of using two reference points, we can use only one reference point, one fixed point only to measure the temperature. He pointed out that there is one temperature known as triple point of water, we can say, at which ice, liquid water, and water vapor, they all coexist in equilibrium. What is the temperature? It is nothing but 0.01 degrees centigrade. 0.01 degrees centigrade is the temperature. At 0.01 degrees centigrade, also known as 273.16 Kelvin, is the temperature at which pure ice, liquid water, and water vapor, they coexist in equilibrium. They coexist in equilibrium. That is known as triple point of water. It is 273.16 Kelvin is the triple point of water. But to convert from centigrade to Kelvin, we have to add only 273.15. 0 degree C means 273.15. Triple point of water is 273.16 Kelvin, 0.01 degree centigrade, 0.01 degree centigrade. 273.16 Kelvin is the triple point of water. But to convert from centigrade to Kelvin, we have to add 273.15 Kelvin. Okay. This is nothing but what is this? 10th CGPM. 10th CGPM. Now, what is 10th CGPM? I will show you 10th CGPM. Now in the Google, I am typing 10th CGPM. 10th CGPM. In the Google, I have typed 10th CGPM. What are the resolutions of 10th CGPM? Bureau of International Void Measures. Resolutions of CGPM 10th meeting. It was conducted on the dates from 5th to 14th October 1954. Okay. Temperature. Definition of thermodynamic temperature scale. The 10th conference. What is CGPM full form? Conference General des Points et Measures. This is CGPM full form. Conference General des Points et Measures. It has defined that to define the thermodynamic temperature scale by choosing, the 10th conference has decided that from now onwards, thermodynamic temperature scale was decided by choosing the triple point of water as fundamental fixed point and assigning it to a temperature of 273.16 degree Kelvin exactly. Okay. 13 CGPM defined Kelvin. What is that? 13th conference is a general deposit measures. The Kelvin unit of thermodynamic temperature is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Nothing but 0.01 Kelvin. 0.01 degree centigrade. So 10th resolution 3 is of 10th CGPM, which had decided that so all over the world, all the scientists have sought each with and discussed with each other, and they decided that thermodynamic temperature scale from now onwards will be based on triple point of water only. It was done in Switzerland. Okay. Next, what is resolution 1? It is about meter. Resolution 1 is about meter, how a meter is defined. What is resolution 2? Resolution 2 is about Richter phase of meter. Resolution 3 of thermodynamic temperature scale. Resolution 4 about definition of standard atmospheric pressure. Resolution 5 about defining temperature units. And resolution 6 is practical system of units. Resolution 6 is length is to be from now onwards. Length is to be measured in meters. Mass is measured in kilograms. Time is measured in seconds. Electric current is measured in amperes. Temperature is measured in degree kelvins. Luminous intensity is measured in candela. These are the practical system of units. 5 resolution 5 is how defining temperature. Okay. All this is in French. This is French language. Official version is in French text. This is French language. If you want to go into English, we will go to English. Now this is in English. This is English language. Okay. Now we will go to our class. Rule number 20 జాయిన్ అయ్యావా మళ్ళీ శ్రవణ్ బాబు ఇందాక ఎగ్జిట్ అయ్యావు. So that is the method in use after 1954. The 10th CGPM in 1954 adapted this fixed point 0.01 degree centigrade or 273.16 Kelvin as the single reference fixed point to measure the temperature. Now Celsius scale or centigrade scale and Kelvin scale, they are distinguished by using the symbols small t and capital T. The relation between these two is temperature in Kelvin equal to temperature in degree centigrade plus 273.16. We have to add only 273.16, not 273.16. We should not add. We have to add only 273.15. 273.16 is 0.01 degree centigrade, but 0 degree centigrade means 273.15. So to convert a centigrade value into Kelvin value, we have to add 273.15. That is relation between Celsius and Kelvin scale. Now Kelvin also stated that temperature is proportional to thermometric property. T is proportional to x. Therefore, T equal to a constant small a into x. What is x? X is thermometric property, means it is length in case of mercury in glass thermometer. T is proportional to L. As the length increases, it is automatically means that temperature is increasing. In constant pressure gas thermometer, volume is the thermometric property. So, as the volume is increasing, temperature is increasing. T is proportional to volume in constant pressure gas thermometer. Next, in the constant volume gas thermometer, as the pressure increases, temperature increases. T is proportional to P in constant volume gas thermometer. In thermocouple, EMF is the property. Temperature is proportional to EMF in thermocouple. In electric resistance thermometer, T is proportional to electric resistance. So temperature at triple point is also proportional to thermometer property triple point. So temperature triple point is also proportional to x at triple point. Therefore, temperature at triple point equal to constant A into x at triple point. Now, if you divide this T equal to AX with TTP equal to AXTP, if you divide one with each other, then T by TTP equal to x by XTP. Then T equal to T at triple point into x by XTP. Temperature triple point is 273.16. T equal to 273.16 into x by XTP. So temperature at triple point equal to a constant into x at triple point. X is the thermometric property. So T equal to A into x. These two equations are divided with each other. T equal to AX, TTP equal to XTP. They are divided. If they are divided one with another, we got TTP equal T by TTP equal to x by xTP. Therefore, T equal to TTP into x by xTP. T equal to 273.16 into x by xTP. If we apply this principle to various thermometers, so first one, liquid in glass thermometer. In the place of x, for liquid in glass thermometer, length is the property. T equal to 273.16 into L by LTP. In case of constant pressure gas thermometer, the formula is T equal to 273.16 into V by VTP. In case of constant volume gas thermometer, T equal to 273.16 into P by VTP. In case of thermocouple, T equal to 273.16 into E by ETP. In case of thermocouple, T equal to 273.16 into E by ETP. In case of electrical resistance thermometer, T equal to 273.16 into R by RTP. Okay. So please note down these things. So how this equation is obtained? We have taken temperature at triple point is proportional to x at triple point. Temperature at triple point equal to A into XTP. Similarly, temperature is proportional to x. T equal to AX. We are dividing T equal to AX with TTP equal to AXTP. So after dividing, we got this equation. T by TTP equal to x by XTP. So T equal to TTP into x by XTP. But TTP is 273.16. T equal to 273.16 into x by xTP. So we have applied this equation to various thermometers. So we got T equal to 273.16 into L by LTP, 273.16 into V by VTP, 273.16 into P by PTP, 273.16 into E by ETP, 273.16 into R by RTP. Like this we got. Okay. Next, third principle is why a thermometer is said to be sensitive. A thermometer is said to be sensitive when it quickly recognizes temperature of the body with which it is put in contact. So if made to touch a body, a thermometer is made to touch another body. If it shows quickly temperature, then it is said to be sensitive. And further, it has to reflect even small changes of the temperature. So in that case, thermometer is said to be sensitive. Okay. So please note down these things. Sensitiveness of thermometer. And tomorrow we will discuss about constant volume gas thermometer and some other scales of thermometer. Then we will do problems on temperature. So a thermometer is said to be sensitive when it quickly takes temperature of the body with which it is put in contact. And if a thermometer reflects even small changes of temperature, also it is said to be sensitive. Okay, dear students, now I am ending the class. If you have any doubts, you can ask me. Absentees are today's now for this class. Rule numbers 4, 5, 6, and 10. Rule number 20 has left and joined again. Good. Okay. If you have any doubts, you can ask in this topic. Now I want to show you how. Now Tanuj, what is your doubt? 21 Tanuj. 21 Tanuj, you can ask. Yeah. Ask me about the PDF which I have shared yesterday. What is the doubt? Okay, Chan, if you are able to unmute yourself, okay, I will give you permission to unmute. Unmute. Okay.
సార్ నిన్న మీరు పీడిఎఫ్ షేర్ చేశారు కదా సార్ నోట్స్లో రాయమని అంటే ఒక దాంట్లో 15 పేజెస్ ఉంది ఇంకో దాంట్లో 52 పేజెస్ ఉంది
52 పేజెస్ ది వద్దు 52 పేజెస్ ది పీపీటీ అది మీరు చూసుకోవాలి ఓకే అదే మ్యాటర్ 15 పేజెస్ నోట్స్ లో ఉంటుంది దాన్ని చూసారండి
ఓకే సార్ అదే డౌట్ ఉండే
15 పేజెస్ నోట్స్ 52 పేజెస్ నోట్స్ సేమ్ 52 పేజెస్ అనేది పీపీటీ అది మీరు ఒకసారి ఇట్లా మీరు కూడా ఆన్ చేసి స్క్రోల్ చేసుకుంటూ చూసుకోవడానికి పెద్ద అక్షరాలతో ఉంటుంది క్యాపిటల్ పెద్ద అక్షరాలతో చూసుకోవడానికి బాగుంటుంది ఈ 15 పేజెస్ ది నోట్స్ అది రాయాలి
ఓకే సార్
ఓకే
yes sir
now I want to show you how to check in YouTube in YouTube to type ZEROTH zeroth law of thermodynamics. So you'll get number of concepts like this. Okay. Zeroth law of thermodynamics.
Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words that make your writing sharp or explicit. Professor Dave here, let's discuss the zeroth law of thermodynamics. He knows a lot about science, Professor Dave explains. Thermodynamics is a tricky subject that must be studied in chemistry, physics, engineering, and many other courses of academic study because it has an incredible impact on the behavior of matter and energy. At first, start to make sense, and you can continue to learn more about the subject as needed for your field of study or level of desired knowledge. We will begin our analysis with the infamous laws of thermodynamics. Just like Newton's laws of motion, there is a first, second, and third law. But later in the development of the field, a more fundamental law was added and dubbed the zeroth law. So let's start there. The zeroth law of thermodynamics deals with thermal equilibrium, which, as we recall, describes the situation in which there is no net heat flow between two systems. The zeroth law states that if two systems are in thermal equilibrium with a third system, then those two systems are also in thermal equilibrium with each other. In other words, if A is in thermal equilibrium with B, which is in thermal equilibrium with C, A and C are also in equilibrium. This may seem like a trivial statement, but it is an important one because it means that two objects at the same temperature will not exhibit heat flow when they come into contact with one another. This marks temperature as the indicator of thermal equilibrium. If two objects are in thermal equilibrium with thermometers that read the same temperature, the objects will be in thermal equilibrium with each other, which therefore allows us to gather all kinds of thermodynamic data in our laboratories. In studying thermodynamics, we must also learn certain definitions. We will want to be able to define a system as the collection of objects we are examining, while the surroundings represent the environment surrounding the system, which is technically the rest of the universe. Some systems allow heat to flow in and out. These systems have diathermal walls. Some systems do not allow heat to flow in and out. These systems have adiabatic walls. No system can be truly adiabatic, but it is a useful approximation when we do calculations involving systems that permit only negligible heat transfer. With these definitions out of the way, we can move on to the first law of thermodynamics.
When you think of accounting and finance, what comes to mind?
These three cups are in thermal equilibrium. I can measure the temperature in all 3 months here with a thermometer, and you can see that they all come up as being the same temperature. I could also use 3 different thermometers, and they would still say that the temperature is the same across all 3 containers. That's because temperature is a fundamental and measurable property of matter. The framework that describes all of thermodynamics can be summed up in the 4 laws, and these describe heat, energy, and their interactions with matter. While the first, second, and third laws of thermodynamics are quite well known, there's actually a 4th law that underpins all of the other laws. It was devised after the first 3 laws, but it was so fundamental and provided such a basis for the other laws that it was termed the zeroth law of thermodynamics. The zeroth law of thermodynamics is actually an observation and states that if 2 thermodynamic systems are in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. Or to put it mathematically, if A equals C and B equals C, then A must also equal B. If all of these 3 glasses are at thermal equilibrium, then we can say that they're all at the same temperature. And this is where the significance of the zeroth law lies. It lets us establish temperature as a measurable and universal property of matter. If something is measurable, then we can create scales for it, and that's exactly what happened with temperature. The first temperature scale that, in a slightly altered form, is still in use today, was established by Daniel Gabriel Fahrenheit in 1724. A more common scale, named after Swedish scientist Anders Celsius, uses the freezing point of water as the 0th point on the scale, and the boiling point of water as the 100th degree on the scale. Rather than using a scale where 0 is defined arbitrarily, what we really want is to use a scale where 0 is the coldest temperature you could ever get to. Scientists around the world use the Kelvin scale, where 0 is defined as absolute 0. Absolute 0 is something that's defined by the 3rd law of thermodynamics, but that's something that we'll get to in another video. Now, it was observed that the properties of matter example, liquids can expand or contract when heated or cooled, and the conductivity of different wires can change as a function of temperature. Some old-fashioned thermometers, such as this one, use the expansion of mercury or other liquids under heat as a measuring tool. Modern electronic thermometers, such as these ones, commonly use thermoresistors, where the resistance of a material changes with changes in temperatures. Yet another way of looking at temperature is using a thermal imaging camera. All objects above absolute zero radiate some sort of infrared frequency radiation, with hotter objects radiating higher amounts of infrared. This allows us to use thermal imaging to see the world even without any visible light. Now, if two objects at different temperatures are brought into contact with each other, then they'll try to reach thermal equilibrium. If the two objects are of sufficiently different temperatures, then the reaction can be rather violent due to a phenomenon called thermal shock, because the heat gradient makes the glass want to expand, but the other side is cold. This causes a strain that breaks the glass. The concept of the zeroth law of thermodynamics may seem trivial, but it lets us define temperature, and that in turn allows us to quantify the effects of the other three laws.
Hello, welcome to the postgraduate program in Artificial Intelligence and Machine Learning offered by the University of Texas at Austin in collaboration.
Okay, students, now you can leave the class. Now you can leave the class.